So let's have a quick reminder of the transformations of y equals f of x that we've looked at in the previous videos. We've got y equals f of x plus or minus a, and this is a vertical shift of y equals f of x plus a units up or minus a units down parallel to the y-axis. We've then got x plus or minus a and the function of that, and that gave us a horizontal shift of y equals f of x plus a units left or minus a units right parallel to the x-axis. We've got y equals negative f of x, and this gave us a reflection of y equals f of x in the x-axis. And we have y equals f of negative x, and this gave us a reflection of y equals f of x in the y-axis. Then we've got y equals negative f of negative x, and this was a half-turn rotation about the origin of y equals f of x. And in the last video, we looked at y equals a of f of x, and that was a stretch of y equals f of x parallel to the y-axis by a scale factor of a. And finally, y equals f of x over a, and that was a stretch of y equals f of x parallel to the x-axis by a scale factor of a. There are two other transformations that we will be looking at, the inverse function and the derivative function, but we will look at those later. So a composition of transformations is when we are applying more than one transformation to a function. So for example, we might do a vertical shift and a reflection, or we could do a stretch and a horizontal shift. So we're going to look at is for the function y equals f of x, sketch the related function y equals a half of f of negative x plus 5. So you can see we've got three different transformations going on with our function y equals f of x. We've got an f of negative x, we've got a half multiplied by that function, and we've got an add 5. And we're going to treat this like BODMAS, dealing with the bracket, then the multiplier, and then finally the adding at the end. So the first thing we need is our function y equals f of x, and that's represented by this curve, and we're going to put the key points on the curve. So we've got our roots, we've got our y-intercept, and we've got our two turning points. The first transformation we're going to look at is the y equals f of negative x. And y equals f of negative x is a reflection in the y-axis. So we're moving all of our x-coordinates to the negative equivalent on the opposite side of the y-axis, and we're leaving all of our y-coordinates exactly lined up with where they are. So it means that we're going to move all of our roots, all of our turning points, but our y-intercept is not going to move because it is where it needs to be. And once we've moved them all, we're going to label them and draw them in. But you do not need to draw in each step if you're doing this in an exam. Right, we've dealt with y equals f of negative x. Now we want to apply the scale factor, that half of f of negative x. So a half of f of negative x means that we're going to scale f of negative x by a half. So that means that this time all of our x-coordinates are going to stay the same, but our y-coordinates are going to be multiplied by a half. So our negative 320 is going to become negative 310, and our 3 negative 10 is going to become 3 negative 5, and then we can't forget about our y-intercept, which is at 0, 6, so that's going to go to 0, 3. Right, now we're going to draw the curve in, and we're going to label these new points so that we know where we're going next. Now we're at our final step now, and we're looking at y equals a half of f of negative x plus 5. So this means we have a vertical shift up 5 of our half of f of negative x. So every single one of our y-coordinates is going to go up 5 units. So let's move our stationary points first. So we're going up to negative 3, 15, and 3, 0. Then we're going to move our roots all up so that we've got our y-coordinate of 5. And finally, our y-intercept goes up to 0, 8. And then we're going to neatly draw our curve in. We're going to mark on every single one of those points, and then we're going to remember to label the curve with our y equals a half of f of negative x plus 5 as our final step.